Standard test method for density, relative density or specific gravity, and absorption of coarse aggregate. This test method covers the determination of the average density of a quantity of coarse aggregate particles, the relative density, and the absorption of the coarse aggregate. Relative density or specific gravity is the characteristic generally used for calculation of the volume occupied by the aggregate in various mixtures containing aggregate, including Portland cement concrete, bituminous concrete, and other mixtures that are proportioned or analyzed on an absolute volume basis. Apparent density and apparent relative density, or apparent specific gravity, pertain to the solid material making up the constituent particles, not including the pore space within the particles which is accessible to water. Absorption values are used to calculate the change in the mass of an aggregate due to water absorbed in the pore spaces within the constituent particles, compared to the dry condition when it is deemed that the aggregate has been in contact with water long enough to satisfy most of the absorption potential.
Apparatus: weighing scale, wire basket, coarse aggregates, oven, water, and water bucket.
The procedure: first, rinse the aggregate thoroughly with water to remove any impurities. Then, soak the aggregate in water for approximately 24 hours. Next, after soaking, gently dry the surface of the aggregates using a towel. Weigh the SSD coarse aggregate and record the measurement at B. Place the SSD aggregates into a wire basket submerged in water and record its submerged weight C. Be sure to zero the weighing balance with the basket before placing the sample. Next, transfer the coarse aggregates into a pan and dry it in an oven at 110 degrees Celsius for 24 hours. Once drying is complete, allow the samples to cool to room with temperature and record its final dry weight at A.
Calculation. So for the data, here is the data we have gathered after the experiment. So for letter A, which is the mass of oven-dried test sample on air, is equivalent to 3,660 grams. For letter B, which is the mass of saturated surface dry test sample in air, equivalent 4,000 grams. And for letter C, which is the apparent mass of saturated test sample in water, is 2,450 grams. In order to get the value of specific gravity, OD, or the relative density, we must follow this formula, which is A divided by B minus C. So that is 3,660 divided by 4,000 minus 2,450, and the answer is 2.4. For the specific gravity of SSD, or its relative density, is B divided by B minus C, which is equals to 4,000 divided by 4,000 minus 2,450, which is equivalent to 2.58. Now for the apparent relative density, the formula for it is A divided by A minus C, which is equals to 3,660 divided by 3,660 minus 2,450, and it's equals to 3.02. Specification or limit and its specifications. For oven-dried relative density, its specification is around 2.5 to 3.0. For the saturated surface dry relative density, its specification is 2.4 to 2.9. For the apparent relative density, the specification is around 2.5 to 3.0. Conclusion. The given aggregate's properties indicate compliance with ASTM standards, making it suitable for concrete application. Oven-dry relative density, which is 2.4, falls within the typical range for natural aggregates, ensuring adequate strength and durability. The saturated surface dry relative density, which is 2.58, suggests moderate water absorption, which must be considered in mix design to maintain the correct water-cement ratio. The apparent relative density, which is 3.02, indicates dense particles with minimal internal voids. Overall, the aggregate is appropriate for construction use, provided absorption adjustments are made in the concrete mix.